In this section, we look at problems to do with compound interest where we're trying to find the present value or the principal. So in this problem, Ginny is 18 years old. She's inherited some money from a relative. Ginny wants to invest some of the money so she can buy a home in Milk River, Alberta when she turns 30. She estimates that she will need about $170,000 to buy a home. A asks, how much does she have to invest now at 6.5% compounded annually? The information that we're given in this problem is we know the future value. She wants to have $170,000. We also know that the number of compounding periods are going to be once a year for about 12 years, since she is 18 years now and she wants to buy the home when she's 30. So that's one compounding period per year for 12 years, which equals a total of 12 compounding periods. We also know the interest rate. It's 6.5% compounded annually. So the interest rate per compounding period is going to be 6.5%, which as a decimal is 0.065. And what we're looking for is the present value, or the principal. So what we'll do is we'll use a rearranged compound interest formula, which solves for the principal. So this is the future value divided by 1 plus I to the exponent n. And if we fill in this information, since we know A, I, and n, we know A, or the future value, is $170,000. The interest rate is 0.065, and the n is 12 times per year. Now, when you're solving for a problem like this, I would suggest calculating the denominator first, finding out what this value is when you add these numbers and then raise it to the exponent of 12. And if you do that, I'd leave a few decimal places, probably a bit more than 4 decimal places even, just to make sure this is accurate. So 170,000 divided by, and if we calculate this, it'd be 2.129096, and probably a little bit more we can leave in. And if you divide these, you would get that the present value is $79,846.09. Now you can also solve this problem using the TVM solver and the graphing calculator. And if you're going to do this, you would need to write out each of these values. And this is really showing your work in the TVM calculator, or the TI-84 graphing calculator using the TVM solver. So if I was using this again, I'll remind you that this is all in the apps section of the calculator under finance and the TVM solver. We know n is 12. This is the number of times the interest is compounded over the 12 years. The interest rate is 6.5%. We don't need to put that as a decimal. The present value we are not aware of, so we'll skip past that. The payments per year are 0. And she hopes to have $170,000. And the payments per year and the compounding periods per year is just 1. So if you go back and highlight the PV or present value and hit alpha enter, we'll get this same answer. Again, remember it is expressed as a negative number in the graphing calculator, and it is the same as what we had here. Now for some of you that may be a bit easier, so if you do choose this method, you just need to show this written down. And you'd show this as a negative still. And then what I'd ask you for your solution is just to put a box around this to identify this is exactly what we're looking for in this solution. So she has to invest $79,846.09 now if she intends to have $170,000 when she's 30. Question B asks, what's the ratio of the future value to the present value for Ginny's investment? And really what this tells us is how much we have to increase our current money by to get to our future value. So all we have to do here is take our future value and divide by the principal. So our future value in this situation is $170,000. And she is investing, or she needs to invest, $79,846.09. Now, if we divide these and we round this to the hundredths place, which is 2 decimal places, you should get 2.13. Now, what this tells us is that her current amount, her $79,846, needs to just over double in value. Okay, so it needs to be 2.13 times as much in order for her to reach her goal when she turns 30.